everyone, welcome to today's video on describing and performing translations. So we'll begin with some key vocabulary and then get into 3 examples. So first, when we're talking about translations, we're in the general unit and umbrella of transformations. So a transformation is a change in the position, shape, or size of a figure. And then we have a rigid transformation. A rigid transformation is a transformation that keeps the size and the shape of the figure the same. So it's not getting bigger, it's not getting smaller, and it's not like making it wavy or like changing any of the angles or changing any of the side lengths. Another way of saying it is it's a transformation where the pre-image and the image are congruent. Congruent is a word you have learned before. That means that the angles are the same and all the side lengths are the same. So we can really think of rigid transformations as you look at it and you see the same exact shape, it's just been moved around. And then within that category, we have a translation. Okay, so that's what we're going to focus on today. And we've already heard a translation as the math term for a slide. But the more technical definition is it's a type of transformation where each point is going to move the same distance in the same direction. And we can see that for our 3 pictures here. We'll start all the way on the right. I have point A. It is getting moved 6 spots to the right. If I choose B, it's also getting moved 6 to the right. And C is as well. We normally focus on translating or sliding the vertices, and those are where 2 lines meet. Okay, so on a shape, it's where like this line segment and this line segment meet and form an angle, these points. But of course, actually every single point on this figure is being slid to the right 6. It's harder to tell, but this point to its corresponding point over here is also being moved to the right 6. And that's true for a point in the middle as well, right? We just can't see it as easily. You'll see that in the other 2 as well. We have our pre-image or the object. Those are the synonyms to each other. It's like the figure we start out with, and then we apply a translation and we get the image. So that's the shape after it's been transformed or translated in this case. So let's get into our first example, which is just identifying translations. So this question is asking us which figure is a translation of figure 1. Explain your answer using the definition of a translation. So I have figure 1 right here, and I want to think which of these other 3 figures is going to be a translation of figure 1. Well, honestly, if I look at this, I would be able to identify that the answer is figure B. I would know it was figure B pretty quickly just by looking at it, because I can see currently I would say this figure is like pointing to the left, pointing to my y-axis. If I think about those triangular edges as like pointing in that direction, right? And that's the same thing for B. We're pointing left. In figure A, we see we're pointing to the right. Something's got moved around. It's got flipped around or rotated around, so it's pointing a different direction. And then it's pointing down in C. Okay, so it couldn't just be slid. But that's not a very technical definition. That's just kind of what I can imagine in my head. So let's go back to the proper definition of a translation. A translation is a transformation where each point moves the same distance and in the same direction. So let's quickly prove that that's what's happening here. I'm going to take this point, and that is going to correspond with that point. I can see they line up. When we do the transformation, this point is going to land on top here. I can label it because that's often helpful. I'm going to call this A, B, C, D. And then the image after the transformation, we often call that A prime, B prime, C prime, and D prime. And all it's saying is these A and A prime, they correspond, they go with each other. But this is happening, A is before the transformation, and A prime is after the transformation. So how do I get from A to A prime? First I have to go up 1, 2, and then I need to go right 1, 2, 3, 4. Okay, so I'm going up 2 and then to the right 4 for point A. Now let's see what happens when I do that for B and B prime. I go up 1, 2, and then right 1, 2, 3, 4. So again, to get from B to B prime, I had to go up 2 and write 4. And I can do this for my other points as well. To get from C to C prime, I'm going to go up 1, 2, and write 1, 2, 3, 4. And of course, the same thing happens with D. So I can then describe that figure B is the translation of figure 1 because to get from figure 1 to B, I moved each point the same distance in the same direction. That's the key language here. We're moving in the same distance and the same direction. Briefly, we can see for figure A, for example, which we know is in a translation, we can't move each point in the same direction and the same distance. To get from A to A prime, we'd go up 3 and then right 3. And to get from C to C prime, we would go up 3 but then left 1. Right, so you can't move all the points in the same direction to get between them, so we know it's not a translation. All right, so we know how to spot a translation. The next step is trying to describe them. So here we see a translation. We want to describe the translation rule from triangle ABC to its image A prime, B prime, and C prime. Okay? So again, we're going to ask ourselves, match up these corresponding points, A and A prime, B and B prime, and C prime. How do we get from B to B prime? And whatever is the case there, that's going to be the same rule that applies to get from A to A prime and C to C prime. Because we are told we have a translation, we can see that it looks like a translation, a slide, so we only actually need to check it for 1 point. It's a good idea to check it for a few to make sure you don't need to make a mistake, but mathematically that's not necessary. Okay, so how do I get from B to B prime? We're going to think about up, down, left, and right. So first I'll try to go left and right. In this case, I'm going to be going right. Okay, so I start with B. I'm going to move 1, 2, and 3 to the right. And then from here, I can go down 1, 2, 3, 4. And when I do that, I will have moved B to B prime. All right, let's quickly check that that works for one of our other pair of points. We'll do it for C. So if I have C and then I go right 1, 2, 3, and then down 1, 2, 3, 4, I'm also going to end up at C prime. And the same would be true for A as well. So all I need to do to describe the translation rule is write that. I'm going to go right 3 and down 4. That's really it. At each point in triangle ABC is translated right 3 and down 4. When you get to high school, you'll see there's more of an algebraic way to write this, and we'll touch on it a little bit. When you're moving right 3, you're moving the x-coordinate 3 to the right, so it's getting bigger by 3. So we can write that translation rule as like x plus 3. And then when we're going down 4, the y-coordinate is getting smaller by 4. We're subtracting 4. So this is kind of a nice way, an efficient way of writing that that has more algebraic and like coding applications, but it's not super important in 8th grade. You'll see it again in high school. All right, and finally, now we've described them, we've identified them, let's perform a translation. So we see, graph the image of triangle ABC after a translation right 5 and down 2. What are the coordinates of the image? Okay, so I'm going to pick, again, really my vertices, where my points on the triangle where the lines meet to form A, B, and C. I'm really just going to translate those and then connect the lines. It is true, though, that like every single point along these lines are moving that way, but if I translate the vertices and then just connect the line straight, then it's going to work. So let's pick C to start with. I have C needs to go right 5 and down 2. Okay, so I will go right 1, 2, 3, 4, 5, and then I'm going down 1, 2. Okay, so this should be my new C, that's C prime. Now let's do the same thing with my other 2 points. B, we're going to go right 1, 2, 3, 4, 5, and then down 1, 2, and we end up right there. That's going to be B prime. And then one more time for A, right 1, 2, 3, 4, 5, down 1, 2. And that will be A prime, because I'm moving A. All right, now it's not super clear what I've done right now. Often these kind of jump marks, they're very helpful to make in the moment, but then it can make it a little confusing and hard to follow. So maybe erase those if you can, or at least just like try to ignore them. So now we just need to connect the points. We know that C prime and B prime should connect and form a straight line segment, just like C and B do. Ideally you have a ruler, but I don't. Then we have A prime and B prime. We're going to connect those. And then C prime and A prime. Again, I don't have a ruler, so it's not the most beautiful picture, but you can see it's the same shape. If I had a ruler, if I drew it perfectly, we would have the same angles, the same side lengths, and it would just be this original triangle, A, B, and C, but translated right 5 and down 2 to make triangle A prime, B prime, and C prime. Now the last thing for this question, it says, what are the coordinates of the image? So we just need to list out what are these new coordinates. C prime is pretty easy. C prime is right here on the x-axis. So I am moving left 1 to -1 is my x-coordinate, and then I don't move up or down at all. I stay having a y value of 0. For B prime, I can see I'm out here at 5 on the x, -2 on the y, so this is going to be the point 5, -2. And for A, I'm at 1, -5. Like I mentioned, in high school, we'll pay a little bit more attention to the coordinates. So you could do this and get these coordinates without actually drawing the shape. You could know that we start at this point C, which was -6, 2. And then to translate it right 5, it means we're going to add 5 to -6, which is equal to -1. And then we're going to subtract 2 to go down 2 from the y-coordinate, which is 0. So we could get that theoretically without actually moving it. But for the moment, it's good to just draw it out, graph it, and kind of see the translation, see the sliding in action. All right, awesome job, everyone.